Get Certified Together program is created by Technocoffee, your free online knowledge sharing website, based out in London.
One of the episode was which document I refer to learn more about CCSP, to cover everything, and from where actually I get hold of the syllabus and what different section we have to cover, what different subtopics and topics which comes in the exam, from where we can get all those information. I am putting one link in show notes, so that's the link of ISE Square organization, where you can simply give your details like your email ID, your name. Hey everyone, welcome again for another episode of Get Certified series program. This is episode number 21 for this whole series, episode number 6 specifically covering the CCSP topics, and episode number 1 for year 23. I'm not really sure whether I should be announcing this whole episode sequences in each episode, but I have written it in the similar way in my transcripts, and to be honest, I'll get confused if I simply change it now. So better it stay like this. First of all, I apologize. I received feedback in last week's episode that it was not clear, the voice was a bit on the lower side, and I was not speaking clearly. To give you guys a bit background, I was recording it in early morning and I cannot really speak in the way I normally speak in louder manner because my family was sleeping in the other room and I don't still have a studio of my own. I apologize again. I'm sorry if you guys have problem hearing it. It was more related to analytics and what's our plan forward. So even if you skip that episode, I'm sure you guys are not missing anything important. So you guys can simply ignore it, and if you want to straight away hop from episode number 19 to 21, it's perfectly fine. Let's go in full-fledged, full throttle from this week onward. But there was an important announcement last week, which was I mentioned that from next week onwards, we will be covering more topics in each episode, and episodes will be bit longer than what they are currently. So currently, almost all episodes are somewhere between 15 to 20 or 25 minutes. So from this week onward, I'm planning to maybe have a 30 minutes episode if I have enough topics to talk about and I have enough information to share. What I also wanted to introduce from episode number 6 is we will be covering a full-fledged good recap of what we have covered already and on which stage of syllabus we are in. This will help us to get ourselves prepared for the upcoming topic in the same day particular episode, and of course it will give us a bit of revision as well for what we have covered already in the previous episode. So that's why the episodes of year 23 will be a bit longer than what they used to before. So before moving to the section where I'll be discussing about the syllabus, how much we have covered, or what are the subsequent topics which need to be covered in this particular episode, let me give you a brief recap of the last week's episode. Like I told you, we discussed a bit about analytics and bit about and how this journey is gonna be look like in the upcoming quarter one of year 23, and how and when we can plan our CCSP exam, because we all are working for the preparation of the exam. Our ultimate goal is to get ourselves certified in cloud security. So that's our ultimate goal, to learn more about cloud security and to get ourselves certified. Now, one of the feedback which I received from my listener in one of the episode was which document I refer to learn more about CCSP, to cover everything, and from where actually I get hold of the syllabus and what different section we have to cover, what different subtopics and topics which comes in the exam, from where we can get all those information. I am putting one link in show notes, so that's the link of ISE Square organization, where you can simply give your details like your email ID, your name, your organization for which you are working on, just few basic information, and then ISC Square will give you a link from where you can download a document. So the name of that document is CCSP Prep Guide, and in that CCSP Prep Guide, once you open and go inside, you will find a lot of hyperlinks. One hyperlink will be having the whole syllabus, which I refer and which I talk about every time when we start discussing about the topics topics which we will be covering in this episode and the next week episode. So those list of topics are available in that syllabus, which is one of the hyperlink in the PDF document which I am talking about. So another important thing which you can find as part of this prep guide is CCSP official study guide. So CCSP official study guide actually covers all the topics, not in as descriptive manner, not in that detailed manner, but it have a lot of information. It can give you a good idea about individual topic and a brief theory about and subtopics and a good brief explanation of everything. So you can also get that free of cost official study guide from the same document which you can download from IC Square official website. So for example, I was going through this study guide, and if you go to page 32 specifically, there was one very good diagram about a cloud service model. We talked about cloud service model in one of the episode where I told you about infrastructure as a service, platform as a service, and software as a service, different way any cloud user can purchase the cloud services from the cloud service provider. So this document have a very good diagram about difference between each service model and what are the components which are covered in each service model, what are the services which CSPs provide as part of each service model offering. So it's very good document, and I am thinking of following this document as well, this CCSP study guide provided by IC Square. Also within this book itself there are some practice questions as well, so that's another very important thing. I was not covering the practice questions as of now in any episode because I kept that part for maybe the last few episodes when we have gone through everything and when we have covered all the topics. Then I was planning to start episodes specifically concentrating on different practice questions. But some people, they have different way of learning. They like to see the scenario by which this particular topic will be coming in the exam. Sometimes we have this tendency to also look at the sample questions while we are studying about a particular topic, so we can get a better idea of how questions gonna come from this particular topic or how this particular information can be asked in the exam. Because CCSP, like we also heard from one of our expert in a previous episode, that it's not a straightforward exam, and we need to understand, we need to see different kind of scenarios in which a particular topic can be in which questions from a particular topic can come in the exam. So those practice questions also are available as part of CCSP free study guide, which they provide to anyone who register themselves on ISC Square. So that's one thing which I wanted to share. I'll put the hyperlink in the show notes, and you guys can go check it out. Go to that link, register your information, and you will be getting this free study guide and syllabus and everything, means all important documents related to the CCSP exam. For understanding the syllabus where we are in as of now, for the domain one, cloud concepts, architecture and design, we have already covered understanding of cloud computing concept. So subtopics for cloud computing concepts were cloud computing definition, cloud computing roles, key cloud computing characteristics, and building block technologies of the cloud. So remember, we talked about CSPs, we talked about cloud service provider, cloud service user, different cloud service models, different cloud computing characteristic. Remember, we have five characteristic: elasticity, on-demand self-service, broad network access, multi-tenancy, resource pooling, measure service. So we have key characteristics related to the cloud. Those are all topics we have already covered from the topic 1.1 of the domain 1. From the same domain, topic 1.2 covers cloud reference architecture. We have covered that as well. We have covered cloud computing activities, cloud service capabilities, infrastructure as a service, platform as a service, software as a service, cloud deployment model, private cloud, hybrid cloud, community cloud, and cloud consideration. What are key considerations someone need to take care of before moving to cloud? So if you can recall, availability, security, privacy, governance, compliance, those are the key consideration anyone have to understand, anyone have to consider before they move their infra or before they move their workloads to the cloud. So these are the things which we have covered already. Next is topic number 1.3, which covers understanding security concepts relevant to cloud computing. It started somewhere in episode number 19, where I covered network security, I covered IAM, and I covered virtualization security. So three topics I covered last time. So for this episode, I'll be covering remaining subtopics of 1.3. I'll be covering cryptography and KMS, key management system, data and media sanitization, and common threats to the cloud. So these are the three topics which we're going to cover today. All right, let's go on with the main topics now. And let me just open my notes. So before going on the main topics for today's episode, I'm checking one more thing because I cannot recall whether I have covered virtualization security. Yes, okay. I'm so sorry. I haven't covered virtualization security as well. So now we have to discuss four topics for today then. Virtualization security, KMS, cryptography, data and media sanitization, and common threats to cloud. So I think today's episode will be a bit longer than what I had anticipated before. But okay, let's do it. Means more the merrier. It will give me more chance to talk to you guys. All right. I think to start the security concept, it will be best if I start with virtualization security. Just remember, virtualization is a very important technology. The whole cloud infrastructure, whole cloud computing concept is actually dependent on virtualization. Whole cloud computing exists only because of virtualization. Now, virtualization is what? Anyone will have this question in mind the moment someone say virtualization is the technology on which whole cloud computing is based on. No virtualization means there is no cloud computing. What is virtualization then? So virtualization by name itself, it means you are virtualizing something. It's not something physical or real, it's something virtual. That is something invisible to anyone's eye. That's very layman or basic term which I'm using for the virtualization. I told you one of the key characteristic of cloud is shared resources. You have different users or different workloads running on the same infrastructure, same hardware. So that's the base of cloud computing. You are having shared resource. You don't need one server, one application model anymore. On one particular physical server, you may run multiple application together. How does this really happen? To make it work, we need a virtualization layer on top of that hardware. So if you have a physical server, you have to install some software, you have to install some operating system. I'm telling you again in very basic term. Of course, there are a lot of things in between, but in very basic, there is a physical server. On that physical server, when you put your operating system, instead of that operating system only supporting one application, that operating system can be clubbed with a virtualization software. Using that virtualization software, now you can deploy multiple application on top of that hardware, and each application which you are deploying subsequently will be treating as if they own the whole infrastructure. They are not aware of the other workloads, other application running and sharing resources together. For them, they will see it as whole infrastructure is allocated to them, to this particular application only. But each application is actually running in parallel on the shared resources, and virtualization software actually help in enabling this whole concept, enabling this resource sharing. By resources, I mean, again, I will go to a different cloud computing concept which we covered already as part of this series as well. Remember, storage, memory, and processor, CPU. So those are the resources, and virtualization is helping these resources to be shared among different applications, and these applications are running together. They are sharing these resources of the same infrastructure. So that's what cloud computing is. So that's why when someone say without virtualization there is no cloud computing, that simply means without virtualization there is no sharing of resource. One very important thing I want to highlight here is I'm using this word application in quite generic manner. In actual world scenario, we don't use the term application or directly application is using the resources, application are sharing the resources of common hardware. Instead, we use the term virtual machine. So I started the whole description of virtualization using the term we have a one hardware or we have a one physical machine. Now, what we are doing on top of that physical machine is using virtualization, we are creating virtual machines or VMs. These virtual machines are in turn used to deploy application. For example, you can have three virtual machine on top of a single physical machine using virtualization. These three virtual machine then can in turn be used to run different application. For example, virtual machine 1, VM1 can be used to deploy a web server or front-end application. Virtual machine 2 or VM2 can be used to deploy a backend database, any MySQL database or PostgreSQL or maybe MS SQL. We can have another database or another storage system or any other use case application deployed on virtual machine 3 or VM3. So what we are really are doing is we are creating virtual machines or VMs on top of a physical machine using virtualization layer. These days, we are also hearing a lot about new technology. Well, to be honest, it's not new. It's quite old now. 5 to 6 years back, it came for the first time. Containerization or containers. I will try to cover this topic of containerization somewhere maybe in next episode because it will be quite confusing if I start discussing about containerization now itself. But just remember that containerization is another use case of deploying multiple applications on the same physical hardware on the same system using shared resources. But the scenario is slightly different than using simple virtualization, which we are discussing related to cloud computing as part of CCSP. I will try to cover containerization somewhere maybe after covering all the topics of CCSP, or you guys can tell me if you want me to cover containerization, then I will surely will cover it in some other episodes. And this brings us to another topic which we covered already, cloud computing characteristics. Remember, I told you only when the five basic cloud computing characteristics are matched, then only we can say that any technology is cloud enabled or any technology is equivalent to cloud computing. If even if you miss one of the five characteristics, then it's not called cloud computing. Virtualization is helping sharing of the resource, which is one of the key characteristic of cloud computing, and that's why virtualization enables the cloud computing. Now, virtualization in itself use a particular software. I told you there will be a software installed on top of operating system, which is helping sharing of the resource. And that software is called as hypervisor. We have multiple types of hypervisor. One in which the hypervisor is installed directly on the operating system. Second, in which hypervisor need an additional layer of software or additional layer of operating system to install itself. These are called type 1 and type 2 hypervisor. Again, I'm going in very basic detail because CCSP exam won't be covering in detail unless you're working in cloud computing or unless you are familiar with these terms before. There is no need to go in detail what is the difference between type 1 and type 2 hypervisor. But in brief, you can understand is type 1 doesn't need any operating system at all. Type 1 can be installed directly on the bare metal or on the hardware. Type 2 need an additional layer of operating system before we can install this type 2 hypervisor. So there is a basic difference between these two, and why it is important to learn the difference between these two hypervisor is different cloud technologies use different type of hypervisor. For example, VMware is a very big company and they provide cloud computing solution and they use type 1 hypervisor. Oracle, another very big company, they use type 2 hypervisor. So every organization, every cloud computing have a different kind of hypervisor or different way of running cloud computing. Why we need to understand as a cloud security professional, why we need to know the difference between two? Because ultimately we need to understand what is the impact or what are the different type of threats or what are different type of vulnerabilities which any cloud computing system can possess if they are using a particular type of hypervisor. So for example, type 1 hypervisor is installed directly on bare metal. So we don't have an additional layer of operating system. If you don't have an additional layer of operating system, then you can understand yourself, right? That additional layer of operating system will have additional responsibility of patching, will have additional risk of vulnerabilities or zero-day vulnerabilities within it. Type 1 hypervisor remove this problem because it's not using that operating system at all. We don't need to install it. In this way, type 1 and type 2 hypervisor, with them, they bring different kind of challenges and different type of security risk and threats to the whole infrastructure. And that's why it's very important to understand the difference between two. By now, we have covered network security, IAM, and now we are well aware of the security risk or security concept relevant to the hypervisor or virtualization layer. Let us now discuss about the data which is stored on that application or that infrastructure, cloud computing infrastructure itself. How we really can make sure that that data is secure, that data is safe, and that data cannot be retrieved by anyone. And if you remember CompTIA concept, we learned a lot about cryptography, encryption. So that same age-old topic we have to discuss again. Encryption and cryptography, they are the one which we still use in cloud computing as well to secure our data. So cryptography is the term which we use for encryption and decryption of our data into non-readable format for any other user. So only the user who owns the data, only the person, only the organization which owns that data can read the information stored on that data by using a proper mechanism, by using a proper decryption key, and using up-to-date latest algorithms to make sure that you are using a secured way of encryption. Encryption, again, we know a lot about it already by now, but just to give you guys a brief about it, encryption, we can only decide about it considering the performance or considering the criticality or sensitivity of the data. We don't need to encrypt all the information across whole organization. There is no need to encrypt whole information which you are storing on the cloud, you need to segregate and only encrypt the sensitive data related to maybe your customer base or related to maybe your organization's sensitive critical document confidential information. So those are the things you need to first segregate and then decide upon that which data need to be encrypted. So that's the general thumb of rule. And of course, then you have to decide how you want your data to be encrypted. You want your data to be encrypted only when it is stored, which is data at rest, or you want your data to be encrypted even when it is in move from one place to another, or one from one system or one user to another system or another user. So that's data in transit. And based on both of them, you need to decide upon what kind of technologies or what kind of algorithms you want to use to encrypt your data. In cloud computing, data in transit is very important because your application is running on cloud, your data is stored on the cloud. So every time you are accessing any information from your laptop, from your workstation, that data is in transit, that data is open, flowing open on the internet, and anyone with proper tools can actually sniff and extract the information unless it is properly encrypted. So data transit is very important concept in cloud computing. And how you can ensure that that data is encrypted and that data is secure. One of the best use cases using TLS or transport layer security. Remember SSL TLS certificates which we used in HTTPS port 443. So that same concept which is used very extensively on the cloud based system. So in cloud, everything is on the internet, everything you're accessing from your browser. Most of even inter-system communication between different cloud deployments is running on APIs. APIs are application programming interface, and those API use HTTPS protocol. So you need to make sure that you are only using HTTPS with SSL TLS security to ensure that you are using encryption when the data is going from one system to another system instead of using HTTP. That's one of key and simple but very important concept related to data in transit encryption. For data at rest, it's quite simple and quite straightforward in terms of cloud computing because you are just storing your data on a particular storage bucket. Maybe in AWS, you are using S3 buckets to store your data, and you need to make sure that that data is encrypted when it's there. Either you can use CSP's solution for encryption or you can use your own solution to encrypt that data at rest. But it's quite simple, straightforward. And related to the same topic comes our next thing, which is key management. So when you are encrypting your data, remember you use public and private key or only single key, which is symmetric and asymmetric kind of encryption. So again, when we are doing encryption, we will be generating some keys. We will be using some keys to decrypt and encrypt the data. And those keys need to be safe and secure always, right? Otherwise, there's no point of encryption if that key is openly available to anyone. So key management in itself poses a great challenge any application or any organization which are using cloud computing. For example, if you are using key management service provided by your cloud service provider, then that means they are encrypting data for you and they are generating keys for you. So you need to make sure you have an agreement with the cloud service provider how those keys are stored. There is no breach of keys. If someone try to hack in the CSP database, they are not able to extract your key information because those keys are something which are owned by CSP. So key management system in itself is a big topic and is a critical area which we shouldn't forget when we talk about encryption and cryptography. Remember, we have to keep our keys safe. Only then encryption is 100% foolproof. Otherwise, there is no point of encryption if anyone can decrypt and anyone can steal the keys and decrypt the information. Now, key management service, like I told you, can be of two types. So one in which we take the KMS service offering provided by the CSPs, which we call as remote key management service, because this is something which is happening remotely, not on the cloud users laptop or not on the organization's infrastructure. CSP is responsible for managing the keys for you. So that's remote key management system. These days, CSP also provide clients or end users to create their own key pair and encrypt the information, encrypt the data stored on the cloud. So that's something we call as client side key management because the client or cloud user is responsible for generating the keys and making sure that they secure the keys properly. In the client side key management system, you don't have any say if something goes wrong with the keys. For example, if someone try to get hold of your keys and someone steal your information, you as a cloud user cannot go to CSP and blame them for anything because you took responsibility of arranging the keys and managing the keys yourself. These two are different but important kind of key management system, and any organization, any cloud architect and cloud data architect, they have to think over and decide which is the best way forward. Should we rely on CSPs for using remote key management system, or should we create our own repository to store all the information related to keys on premise on our own system and use client key management system? So it's very important to understand which way to go forward. All right, so let me rewind a bit. We have already secured everything from user access perspective using IAM, identity and access management. We have understood that everything is flowing on the internet and everything is still using network equipment, network routers, internet gateways. We have to make sure that network security is also in place. We have made sure that hypervisor or virtualization security is already there. Our data which is stored is encrypted and the keys which are encrypting the data is also secure. What will happen if tomorrow any cloud user want to take out their data from the cloud and maybe put it on a different cloud, or maybe they simply want to move from private to public or public to private? Any kind of x number of scenarios can be there where ultimately you plan to destroy everything, you plan to move out and just remove everything, you want to clean up everything. In this particular scenario, we need to understand about how we can clean up everything, how we can erase everything without anyone else getting hold of our information. So if we are storing our data on cloud, tomorrow if I remove that information, if I wipe off that information, can we ensure that this particular data which is wiped out cannot be extracted by advanced softwares by someone else? It is completely erased. It is very gray area again, because this is something which you are doing on cloud now. If you are having a old kind of technology where you are storing everything locally, then you can simply destroy those tape drives or hard drives. You can use advanced software yourself and make sure that all information is completely degaussed. You don't have anything in readable format on that particular tape drive. If you are storing any information on cloud, you cannot do that thing. You cannot simply go to data center of the AWS or data center of Azure to wipe everything. We cannot do this in cloud computing. So there are two workarounds in this scenario. One is erasing, simple erasing, which is we try to use advanced software to erase and make sure at our best effort as an end user, we do our best effort to erase the data at max as possible. And second is overwriting. So overwriting is after deletion, after we remove every information, we write more information on top of existing data. Then we wipe it off and put more information on existing data. So in this way, overwriting and erasure, both in terms of cloud computing, are not a foolproof 100% solution, but they simply make it tough for anyone to retrieve the data. So unfortunately, so far I'm still exploring more about this particular topic, but so far the information which I got from my personal knowledge and from my personal reading is these two solutions are not 100% foolproof, and this is a bit gray whether how we can actually make sure that our data and media, our information which we used to put in the cloud and now we want to remove it and want to make sure that it is completely unreadable. Can we really do it? Can we really make it completely unreadable or untrackable? Or is it something still anyone can retrieve if they get hold of data center? Okay, we are almost towards the end of episode 1 of year 23. Topics which I covered in today's episode were cryptography and key management system, data and media sanitization, including overwriting and cryptographic erase, and virtualization security. For the next week episode, I'll be covering common threats for the cloud computing, as well as next subtopic of the domain 1, which is understanding design principles of secure cloud computing. So we're gonna explore more towards secure data lifecycle, disaster recovery, and business continuity planning. So a lot of new topics will be covered in that episode, and it will be good for you guys to check that out. Meanwhile, you can check the show notes as well to download the CCSP Cybex document, which will provide you a good idea about all the topics which we are covering, as well as it will have some practice questions as well. So if you are interested in looking at the practice question while reading and learning new things, then it's a good document for you guys. So you can just download that document and just check it yourself. See you in the next episode. Goodbye and good luck.
Thank you for listening to Get Certified Together. If you loved our content, then please like and subscribe from your favorite podcast platform so you don't miss the notification for our next episodes and announcements.